My name is Darshit, and I'm excited to be hosting this 40th webinar in our Godrej Storage and Handling Knowledge series titled Innovating Ri Charging Process for Sustainable Charging Solution in MHE Trucks. Before I proceed to introduce our esteemed speaker for today, let's take a moment to reaffirm the fundamental mission of our Godrej Storage and Handling Knowledge Sharing platform, designed specifically for the intralogistics domain. I would describe it as the embodiment of the Godrej way of returning the knowledge we have accumulated over the past 6 decades to the broader society and industry. It is our way of giving back of sharing our wealth of experience and expertise with those who can benefit from it. I'm delighted to report that the response to our platform has been overwhelmingly positive. This warm reception has served as a tremendous source of motivation, encouraging us to sustain this initiative. Today, we proudly stand at the fourth year of this knowledge sharing series, dedicated to enhancing the understanding and advancement of intralogistics. Coming to our topic, in today's world, the need for sustainability and environmental consciousness is paramount. We are all well aware of the urgent need to reduce our carbon footprint, transition to cleaner energy sources, and seek innovative solutions to address the challenges of the 21st century. This is especially true in the realm of material handling, where electric MHE trucks plays a critical role in warehouses, distribution centers, manufacturing facilities, and logistics operation worldwide. MHE trucks are the unsung heroes of our supply chains, quietly working behind the scenes to ensure the products and materials move efficiently from point A to point B. However, these essential vehicles are often powered by traditional charging systems that can be far from sustainable, and the associated environmental impact are concerns we can no longer ignore. Our webinar today is here to explore a game-changing solution to these challenges, the innovative RI charging process. RI charging represents a revolutionary approach to charging MHE trucks that not only promotes sustainability but also enhances efficiency, productivity, and cost effectiveness. And about the speaker, it is my distinct pleasure to introduce our distinguished speaker for today's webinar, Mr. Anand Shewalkar, who serves as the National Sales Director for India and neighboring countries in the business unit of Perfect Charging at Fronius India Private Limited. With over 2 decades of invaluable experience in the automotive and industrial vehicle ancillary business, Mr. Anand Shewalkar has truly distinguished himself as a seasoned expert in his field. His career has been marked by a profound understanding of these intricacies of ancillary products and services that are pivotal to the functioning of industrial vehicles, ranging from lubricants and tires to batteries and chargers. Mr. Shewalkar's journey in the material handling equipment industry is noteworthy, spanning 6 to 8 years. During this time, he has become a passionate advocate for sustainability, focusing on educating and supporting MHE customers in adopting the right practices for sustainable charging of MHE vehicles. His expertise in this niche sector has been instrumental in driving positive change and enhancing the efficiency and eco-friendliness of MHE operations across India and neighboring countries. His dedication to sustainable charging solutions and his deep industry knowledge make Mr. Shewalkar a valuable asset to our webinar today. We are fortunate to have a speaker of his caliber who can shed light on the latest innovations in RI charging and provide valuable insights into the future of MHE truck sustainability. Before I move on, I would request everyone to put in their questions in the chat box on the top right of your screen. We shall try to answer them straight away or towards the end of the session. Please do not forget to write your name in the box above the Q&A section. That will help us to get back to you after the webinar in case we miss your question. It is our hope that by the end of this webinar, you will be inspired and informed about the immense potential of RI charging in transforming the landscape of MHE trucks operation. Without further ado, let's get started with today's session with Mr. Shewalkar. Over to you, Mr. Shewalkar.
Uh, Mr. Dashit, thank you very much for introducing me to your audience. And Really thankful to Godrej Metal Handling as they have started this series 4 year back, storage and handling knowledge series. I am your regular viewer and I am gone through various innovative uh, products utilizing into the MHE industry. And that way, Godrej is really doing a great work in Indian market to put in the innovative ways to represent the material handling products. So as the customers of India, uh, being as an Indian material handling market is a growing in entire globe, uh, getting the advantage to understand the global innovations and adopt it in their warehouses. So thank you very much for this platform to introduce us. I'm Anand Shewalkar, as introduced by Darshit. I am working with Fronius India, and we are representing metal handling battery chargers in Indian market. So today we are discussing about the innovative ways of charging into metal handling. Metal handling industry is quite from last 30 to 40 years, dominantly using the electric vehicle. Almost 60 to 70% of fleets are electrical fleets. And predominantly the lead acid batteries are being widely used globally into this segment. Recently, lithium-ion batteries has also started uh, getting their efforts in this industry, but still we are very much dependent on the lead acid batteries. Uh, Fronius, where I'm working right now, having 75 years of experience in this industry of battery charging. And I wanted to tell you the story of that only as innovation. It is in generic charging business. The innovation that way, if you see in India, it is not that much popular. So we at Fronius in 2016 started educating Indian customers on the innovation part of battery charging. RI charging is the process. It was invented by Fronius in 2013, and from last almost 9 years, they have implemented it successfully globally, and customers are getting the benefit out of this. In India, from last 6 years, we are promoting this. RI charging is a process of battery charging of lead acid for sustainable charging solutions for metal handling industry for MHE truck. So I will take you through the insights of the charging process and how it will be benefited to the metal handling industry and overall the sustainability of the industry with green initiative. Yeah. It is a RI charging process adopted into the metal handling charging. What make it difference than the another charging processes? Right now, as a conventional charging process in India, we are using 50 hertz transformer based charging with the charging characteristic called IUI. But this particular charging characteristic, which is a conventional charging process, is a predefined charging characteristic, where if there is a charger with the 60 amps output, so when the batteries get connected to the charger, predefined charging current, probably the set charging current in the terms of 60 amps charger, 60 amps will be put into the battery for charging initially. This is the normal practice from so many years is being used. But with this predefined charging process, there are some disadvantage is there. When the batteries get discharged 80% on the vehicle, MHE vehicle, the normal practice as per the battery manufacturer recommended that for 1 or 2 hours, the battery should keep idly to cool down. There is a reason behind when the battery is getting discharged, drastic discharge that way, the inner resistance of the battery and because of the resistance, temperature of the battery is also getting increased. So when the temperature of any particular electrical body, here we are talking about the battery, when the resistance is high, and if you put the charging with the higher current, so the current which should be converted into the charging, it is not happening that way, and it is converting again into the heat. So while charging of the battery with the conventional charging, with the highest resistance or higher resistance, not charging initially, only creating the heat into the battery. And the heating of the battery is the main enemy of the traction battery. That is always been diluting the battery life and the battery performance both. So with the over 75 years of experience of battery charging, this innovation has come into picture where the researcher has understood that resistance is the bottleneck. So how to understand the resistance and how to charge the battery? So with this charging technology, they understood the resistance first. So once the battery after discharge get connected to the charger, initially 5 to 10 minutes, charger will not start charging. After connection, charger will first diagnose the battery current condition, and with the voltage, current, and the resistance of the battery, it will understand the current situation with the battery age. Okay, so once they understood the resistance level of the battery, current from the charger will be flowed according to the resistance level. It means that the level of resistance, with the level of resistance, that much current only fed into the battery, which current can convert into the charging. Suppose at the certain level of resistance, only 2 ampere or 3 ampere current can be converted into charge and not 10 to 15 ampere. So that 2 ampere only will be put into the battery initially. Gradually, when the resistance will get down, it will get decreased. Then the quantum of current will be increased. And when at the certain period, normally it is at the 20 to 20, after 25% of charging, the resistance will be at the lowest level. That time there will be the highest current put into the battery for the getting the gravity, desired gravity of the battery. So in this entire process, you can see here in the presentation, there is a green color lane, that is a resistance. Then you can see in black, that is the voltage built up while charging, and red color is current. So you can see here in this graph, when initially the resistance is high, the quantum of current is low. Gradually, the current is getting increased at the maximum level, somewhere between 25 to 30% of charging time. And then once the gravity get built up, current again get decreased. So while doing this particular charging process, you can see from, if you see the graph from 0 to 25%, in this particular era, initial charging period of 20%, or if you consider initial 2 hours of charging time, here we are only putting that much current, which will 100% will get converted into the charge. So in this process, we are not creating the unnecessarily heat or temperature into the battery, because when battery is on the while charging, the battery temperature always get increased almost by 10 degrees Celsius. But adopting this RI charging with the resistance based charging, we are reducing almost 4 to 6 degree Celsius temperature while charging the battery. So ultimately, the battery charging is at cool and gentle way with the lower temperature. And so as the battery overall performance of charging is very healthy, because of that, battery service life is getting increased. Because whenever you have a battery charging with the cool and gentle way, ultimately your battery life will get increased, service life will get increased. So after this complete charging, what is the advantage? Another advantage is RI charging is a auto equalizing. When the battery get complete charge, every charging cycle, this charger through the data logger will understand how much current to be required to give into the overcharging phase or recharging phase, or we can say the equalizing phase. And that quantum of current will be given in the pulsing with every charging cycle, so that when we have 8 hours of charging time, so almost 7 or 30 minute actual charging will happen, and remaining half an hour or 1 hour will be the equalizing will be done. So put together all, RI charging is taking care 100% security of your battery with the cool and gentle charging with the equalizing. This last part of equalizing is very much important, because in material handling batteries, it's a 2-volt system and number of cells are connected in series. If these cells are not equalized charged, then the battery backup get reduced, and the sulfation is the major part, which is reducing the backup of the battery and the life of battery. This happens. So in this RI charging process, two important factors been taken care: cool and gentle charging with the reduction of temperature while charging, and giving that much current only which is required by the charging process at that resistance level. Second is auto equalizing the battery, so all the cells to be get equally charged with every charging cycle. So this is the benefit which you can see here on the graph. But what exactly the benefit? Where this benefit you can see? So I will show you the further part where exactly the benefit in the terms of monetary gain you have. The first and more important factor of RI charging is the reduction of energy cost. Because initial 25 to 30% time of charging, we have not wasted the energy, because battery charging is required very heavy energy to be consumed for charging the batteries. So when we are saying that initial time we are not giving the more current, so saving the energy. So overall in a battery charging for 8 hours or 7 hours, whatever is the battery charging period, almost we are saving 30% of grid energy to charge the battery 100%. And this 30% of energy is a monetary gain. And if you calculate this energy with the number of fleet, if you have a 10 number vehicle or 30 number vehicle, if you increase the vehicle quantum and you calculate this 30% energy, you will see it is a potential very good saving for any fleet management of material handling. So this particular savings, what we are talking, 25-30% saving with this RI charging process we observed. This is not only theoretically what, or it's at a laboratory level. We at everywhere, whenever we approach the customer for this RI innovation charging, customers definitely will ask for the practical demonstration, and they want to see this practically to be happen on their side. So we have done this kind of trials at many locations. And one of that, I just wanted to show you practically how we do. We put the energy meter to the conventional charger. We put then we calculate. We put the energy meter on conventional charger, and for let's 10 to 15 days, we charge the battery through the conventional charger, and we calculate all the energy reading. Afterward, being as a RI charging with the supported by the data logger, where the energy meter is already inbuilt into the charging process there in the charger. So we take the data from that energy meter inbuilt in the charger on the basis of RI charging. So we do the comparison. There is one small comparison is given there, like first 13 days with the conventional charger and second 30 days is a RI charging process. So very prominently we can get the conclusion that there is a 25 to 30% charging current saving, this 30% energy saving is there. So this kind of trials we have done in many locations. After this presentation, if any customer would like to approach the benefit in the terms of practically, we are there always welcome to do this such kind of a trial so the customer can experience this technology, this innovation, and be implement at their fleet management to get the benefit of the energy saving. So this is at the energy part, 25 to 30% energy saving with this charging process. Second important factor, that is the battery service life. How the battery service life will get increased. See, typically when we do the charging with the conventional charging process, predefined charging current. So battery and charger have no communication as such in between. So whenever the battery is 80% discharge, and the conventional charger, which is predefined, it will starting the charging with the decided current. No communication. They don't understand each other. They don't communicate. Here, charger is communicating through data. They're taking the data from the battery and appropriate converting into the current required against the resistance. So here we are reducing the charging temperature. That is the main part here. How the battery service life will get hampered, will be increased or decreased. That is depend on the charging temperature. As in earlier PPT, earlier page, I said you, while charging 10% of 10 degrees Celsius of temperature always been there while charging higher temperature 10%. So that will always been reduce the life expectancy of the battery. So with the RI charging process, since we understand through this the age of the battery, temperature of the battery, and the state of charge of the battery. Okay, because of all these parameters to understand, we give the charging current, which is appropriately reducing the charging current by 4 to 6 degrees Celsius and minimizing the any harmful warming of the battery. I'm again repeating, minimizing any harmful warming of the battery, and that improve the battery cyclic life. So if you ask any particular battery manufacturer, what is the ideal life of the battery? They have calculated on the lab basis or on their own research basis. They have their own ideal life cycle of the battery. Suppose we say any manufacturer will say my battery is having a 1300 life cycle of battery. So in that particular life, 1300 life will be get completed with the healthy charging. But with the conventional charging process where you are creating more heat into the battery, you will never get the 1300. You will get somewhere 900 or 1000 life cycle, where almost 1 year of life getting reduced. So as your burden, your cost burden on the investment into the battery will increase. Here, this RI charging will play an important role because of this charging process where it understand the actual situation of battery and give the appropriate current and reducing the temperature of charging while charging. The life acceptancy and the life cycle of battery is going to improve. Improve up to what extent? The recommendation of the battery manufacturer. Suppose battery manufacturer is saying that 1300 cycle is my battery life expectancy with the ideal condition. So this process will guarantee you that you will get this 1300 life cycle with that particular charging process. So as from 1000 to 1300, you will be having 300 cycles will be extra, and that is what almost 10 to 15% more efficiency of your battery life expectancy will increase. Almost 1 year of life is getting to improve. So the burden on the cost of the battery purchase will reduce by 1 hour, and there is a saving of the battery cost. So these are the two important parameters are there. And this is what is, as I said, we have tried it on field at the customer side, we have proved. But initially when this RI charging process is patented by the Fronius, they have done the life cycle test at one German agency called ZVEI. In their datasheet number 8, you can see this reports. This is the agency, the Central Association of Electrical Engineering and Electrical Industry, ZVEI. They have done these trials at their lab to understand the advantage of RI charging over the conventional charging. The battery charging technology and the mode of operation can influence the service life in another way. So they have tried this into the lab where the temperature from 30 degrees Celsius to the furthermore to get increase. And this is environment they have tested, and they have found that the higher temperature strongly influence the service life. But here in this case, when the temperature is get reduced while charging, the degradation or corrosion of the battery is not happening with this charging process and making the battery healthy. This report is generally available on the website of ZVEI. You can see there. So they have done the charging process with the conventional charger and RI charging process. When you see the while charging with the conventional charging, high frequency charging, they have got 44 degree temperature for 4 days. But at the same time, when the temperature is rising there, you can see the peak. That peak every day there is a peak of temperature is there. It is very high in the terms of conventional charger. But when you see in the Fronius charger, which is mentioned in a red lane, the peak is very low, and the overall temperature of the battery in the charging process in 4 days is 39.4 degrees Celsius. So almost 5.4 degree Celsius temperature is lower than comparison to the conventional high frequency or transformer based charging. And that is what is the cooler and gentle charging provide you the good sustainable charging process and the better life of the battery. And particularly, I say this RI charging is backed with the data logger inside into the charger, and it gives the data in the iSpot Weaver. One tool is there where the customer can see all the charging related data stored for the life cycle of the battery, where you can see all the things, number of cells connected to the battery, nominal voltage of the battery, customer, what kind of a charging time he has selected. There is an option from 5 to 6 hours to 11 to 12 hours. So customer can select the charging hours, start of charging time and the date, end of charging time and the date, total charging time required, total AH inputted into the battery. Okay, battery is 100% charged in that charging process or not. Then start voltage after 5 minutes after charging process start, and the end voltage. So overall, a total number of AC energy consumed by the charger for that particular charging that battery. Okay, and while during the charging, if there any error has come, error occur for over voltage or low voltage or any particular fault has occurred while charging, that error also is given there with the state code in this iSpot viewer. This particular data is there for the education purpose. Like customer can check the data periodically at their end, and they can check how the RI charging is performing on their battery, how much energy saving is happened, how the battery is healthy while charging, what are the error code has come, how to rectify the error, how to improve the further charging process. So the customer can get the more sustainable energy saving while charging. So this data is available with the, and this data is available with the customer even. He can himself can collect the data from the charger and put on the iSpot and can check the data. So these all particular RI charging in the larger prospect, when we say any particular material handling fleet having 50 or 100 chargers or 200 batteries or suppose with them, can they see overall picture after implementation this RI charging process, how much monetary gain they can have with this charger for next 5 years, because they would be investing in this charging process. So there is a tool available called ROI calculation, where some minimum data is required to put into this particular tool, like number of forklift, battery, voltage and ampere hour, shift operation, single shift, two shift or three shift, charging time required as per the customer need. and accordingly automatically the charger voltage and current is been selected by this tool. Then we have to give the in that particular area what is the cost for energy in that term. And after putting all this requirement, we can get the calculation. We can get the total saving in the 5 year with this investment or this uh, RI charging process. So what are the parameters are being calculated into ROI so that customer can elaborate it properly. So the main factors into the ROI calculations is energy saving in kilowatt per hour. Also, the major factor here, because we are saving 25 to 30% energy, so you can imagine how we are taking the green initiative for the environment by saving or by reducing the CO2 emission for the environment. And that is what is the basically the current requirement of any industrial facility, where how they are the environment friendly and how their factory is not harming the society nature by reducing the CO2 emission. And here we can provide them the exact how much kilogram CO2 emission they can reduce while this RI charging process. So energy saving in kilowatt per hour, emission saving in the CO2 kilogram, energy saving in rupees, okay, with that quantum. Also, because of the cool and gentle charging, there is a reduction into the water filling into the battery. That also get reduced, cost of water filling and the manpower required. And as I said, 10 to 15% of the battery life cycle will improve with this process. So how much money in that term of battery saving will be that is also been calculated here. And total saving cumulative from first year to 5 year with single battery and multiple battery as a total cumulative also we can see here in a broader prospect to showcase the green energy project or sustainable energy teams are available in every company to whom the basic work is given in the factory, whatever the unnecessarily energy getting wasted or any impact on the environment because of the energy and because of the CO2, those fertility of sustainable energy management team or efficient energy management team available in every company can calculate this data, and they can advise their management to be get implemented this RI charging process for the betterment of company and the society. Here in this way, we will always help our customers to calculate all these things. The important factors, it's an investment. So what is the payback will be get in this investment? So it is additional investment to the customer. So with this 30% energy saving, we understood by the practical observations that between 1 year to 2 year, we are getting the payback. So once the investment is done, within a 2 year, you will get the payback of your investment. Initially, because it's an additional investment, maybe first year it will becomes in a negative, but after the recovering the cost and nullify the investment for next 4 years, you will get the very good savings in the terms of monetary gain. So the next is, with this particular RI charging, what are the advantage are there with this charging process? RI charging is what is the heart of this particular system. USB interface is there. The data in a data logger which is stored, we can extract the data and we can see the data in the iSpot viewer for the educational purpose and the correction into the charging processes, and give the training to our technicians and the operators how to better handle the truck. Like if somebody's some operator is doing the opportunity charging, every 1 and 2 hours is disconnecting the battery, which impacts the battery life. Here in this data log with this iSpot viewer, we can see how many time he has connected and disconnected the battery, and we can educate these users that don't use the battery in this way. Do the proper charging, do the at least 6 to 7 hour charging continuously, manage your operation accordingly, your charging operations, charging frequency. So your battery will get charged properly and and the vehicle will be always available for the operational efficiency. So for this operational efficiency and all this factor, there is a calendar function is available. So as per the customer requirement, they can fix the different charging characteristics for the betterment. Then the important factor in this charging process is that this particular charging devices are coming with the multi-voltage aspect, where 80 volt charger can be easily charged automatically 48 and 24 volt battery. So if there is any wrong assignment for 80 volt charger, if any user has connected the 48 volt battery or 20 volt battery, this charging processor automatically says that this particular battery is not 80 volt battery, and it will calculate the cells of the battery, and accordingly it will take the final decision that this battery is a 48 volt battery or 24 volt battery, and automatically it will start the charging of the battery to safeguard the battery interest and charge appropriately. These are the advantage with this charging processes are there, and the important advantage is the auto equalization of the charging process. Every charging cycle will do the auto equalization. This is what is the RI charging process. And innovation is not always only one time. Innovation is a continuous process for the sustainable future. Every year, every aspect, we should be do the research and innovation to do the system more effective, more sustainable. So the customer, the environment, the society will get the always more advantages. So what next after the RI charging? With the RI charging, the next innovation aligned with the RI charging is tag ID, tag ID guided charging. What is a tag ID guided charging? It's again a new innovation. This is the basically our intelligent battery sensor technology. This battery sensor technology will help the battery charger to get the accurate data of the battery. Accurate data of the battery, because this tag ID device will be implemented on every battery, and this will continuously taking the data from the battery and transmitting this data from the tag ID to the data logger of the charger, where the RI charging will take care automatically to charge the battery. Why this particular tag ID is being invented or implemented? The specific reason for that is automatic detection of the voltage, because in one particular fleet, let's say there are the 50 or 100 vehicles are there. Not necessarily all the batteries are 80 volt or 48 volt. Some of the batteries are there 72 volt, some of them are 36 volt, some of them are 30 volt. Okay, so different battery age is there. With the RI 80, 48 and 24 is automatic. But what about 72 or 36 or 30 volt? So with this tag ID, this will help there, because this is configured with that particular battery. Suppose one battery is a 72 volt battery, this tag ID is configured on that battery with the 70 volt system. And when this particular battery will come for the charging with the charger for the RI charging process, first of all, this particular charger will understand from the tag ID that this battery is a 72 volt battery. So it will acknowledge automatically and start the charging according to the 72 volt charging system. So this is the major advantage. Second advantage, sometimes it happens that because of the not proper uses of the battery, opportunity charging, abuses to the battery, battery not getting proper equalized charge. If suppose the charging is not proper and we newly adopted RI charging with the tag ID on the battery, where the earlier conventional charging was there. Once this particular system is being adopted by the battery, if the battery is sulfated and the battery is and some of the battery cell is gone to deep discharge, this tag ID is automatically will sense the battery condition of the deep discharge or sulfation, and it will give the instruction to the charger that this particular battery is under the threat with the deep discharge, or the sulfation is more occurred into the battery, and automatically the charger will start reducing that sulfation. So this particular battery with RI charging and tag ID will be doing the perfect work of battery regeneration also. automatic battery regeneration. People are here and the customer is here and there searching for the regenerating company and asking them, taking the quotation, sending the battery outside of the factory and doing all this stuff, spending more money. It is not required because it's available in your system only. RI charging, tag ID implemented on your battery. So the automatic sensing of the battery condition in terms of sulfation and all is there, and which is automatically sensing it and recovering it automatically by this charging process. And all this recovery and everything you can see on the data logger through extracting the data, and you can understand what was the situation in your battery in a worst condition and how your battery is now healthy. So this is what is it, the innovation is there further as with the name of tag ID here. Basically, this tag ID is equipped with the level sensor and the temperature sensor. This everything is happened because of automation of the level sensor. Because this is also one advantage here in tag ID. If the electrolyte level in a battery has reduced drastically, the level sensor of that tag ID will automatically sense the level of the battery, and it will give the instruction to the user on the display that your battery electrolyte level is reduced. Please top up the battery with the distilled water. But if the operator is not doing it and wants to charge it, but that is a wrong. With less electrolyte, charging the battery is damaging the battery. So the charger will see if the operator or the user is not topping up the battery. Charger will automatically stop the charging process till the time the user don't top up the battery at the appropriate level. This is what is again a big advantage where this process is taking care the level of electrolyte also automatically and giving the instructions. And if you don't follow the instructions, it will stop charging. So this is the automation there. With the temperature sensor, it always calculate temperature. So it again become very easy to RI to make it more efficient into the terms of charging, because I earlier said the temperature is the biggest enemy of the charging process. This is the one part. What is the another part of the innovation there? Again, there is an innovation. What is called it as the charge and connect, the connected charging solution. This is the today there is a industry 4.0. We implement the industry 4.0 in our factories for the betterment of the factory. So with this industry 4.0, we initiate the automation into our all the respective areas of the production facility, warehousing and all. Why not there? It is into the charging process. We can use the automation and make our sustainable charging in our charging area into the industrial trucks. So this particular charge and connect will be the centralized monitoring real-time data of your charging. The iSpot Viewer will generate all the data which is stored into the battery. You have to extract it by pen drive. But when you do the charge and connect implementation automation, real-time data of the charger, when the battery is getting charged, what is the initial current of the battery, what is the voltage, what is the charging time required, what is the age has inputted into the battery, what was the error, what is the temperature of the battery, everything, every data, real-time data, you can see in your central monitoring for number of batteries at one place. So this will help you to understand which battery is charged early, so you can use that battery and you can deploy another battery for more hours of charging. So right use of battery will be happen there. Okay. So what are the advantage? Full control on your cost. You can monitor all your battery at centrally. More transparency and full control of your charging infrastructure. Better predictability and planning. This is very good for planning. Total cost of ownership. Higher efficiency. Minimize the risk and reduce the cost. You can see here the number of charger is connected. How the connection is happen, how the centralized automation will possible with this charge and connect. There is a web portal available with this charging process. Individual visualization possible with this charging infrastructure. You can see the individual charger real-time data at your monitor. The status monitoring of maximum transparency. You can monitor the status of your real-time status of your battery. connected battery charger, continuous and always. This will be always on monitoring. The charger will 24 hours are there on the monitoring for the automation under the Industry 4.0. Easy access to your charging data. You can see the data real time, always up to date. All the software which is updated in the charger will get automatically updated. Conditional monitoring. Conditional monitoring of the charging infrastructure. Okay. Demand side management. This is a very important factor. Many locations in many areas, specifically the warehousing areas, you can take the consideration of the one place in India called Bhiwandi. Hundreds of warehouses are there. But if you see the energy cost is 15 rupees and 18 rupees are there. And at a time, if you are putting all the batteries to be charged, you can see the peak of your current consumption is there. Why to increase that much energy cost? So we can make the demand side management. We can select which are the battery, when to pick, how much battery to be charged one time. All this automation you can do the possible, and you can reduce your charging cost with the this per unit charging cost. You can reduce predominantly, and you can save the money. You can save the environment. So this is how the RI charging will benefit to uh, battery, to the fleet owner, and to the environment. So consistent innovation in charging process and adopt the new technology will be the only solution for sustainable future. And that this company Fronius believe in that, and they are always in research and development to go for the betterment. So this is what is the RI charging. I try to explain you. So thank you very much to try to understand this new innovation, and I will further over it to Darshit to say on this further things. Darshit.
Thank you so much for the insightful session, sir. This is an eye opener wherein we could see 30% direct saving on the energy consumption, and as well as monetary benefit on that. And even not even the charging of, we are talking today charging of MHE batteries. Okay. So, what if these technologies would mention, this technology comes to your mobile and EV charging as well? Means, it would be like, I don't know whether it is already being implemented in EV charging, but this is a great boon, sir. Means the way you explain us the temperature, I personally didn't know about the temperature that is so harmful for the battery. But yes, is this a patented technology, sir?
Yeah,
Fronius?
this is patented by Fronius International in 2013.
Okay, great, sir, great. So, how does this company, I mean, Fronius is proceeding with it? Have you confined yourself with the MHE charging, MHE battery charging, or you are moving further in other domain, industrial vehicle domain as well?
See, this is basically this charging process, which is RI charging, is designed for the traction batteries. So this traction batteries
Traction
wherever being
batteries.
used, because the
Correct.
maximum it is used into the material handling, like battery operated pallet truck,
Correct.
reach truck, AGV, VNA. Apart that, man lifts are there, and wherever the traction batteries are, platform trucks are there. In all the batteries, this technology is effective.
Yes, got it. So we will take few questions, though we are running out of time, but there are many interesting questions that have come up. So I'll move with the first question. Are there any specific safety measures or consideration associated with the RI charging process that the user has to take care?
No. This is the very protected and research.
Sophisticated.
Yeah,
Yeah,
it's a very sophisticated, and it's everything is been taken care. It's already this technology working on the high frequency charging technology. So whatever the risk was there, it is not there now with this charging technology. It is very
Correct.
convenient, very easy for any battery to implement at any level. new battery, very old battery, moderate battery, whatever the condition of the battery is there, this particular charging system will help that battery in a safe way to recover and continue charging properly.
Great, great. So the second question is, does RI charging work differently for a battery or MHE working in cold storage application?
The cold storage application RI is also working. Uh, Basically, when it goes to the cold storage application, there are the additional accessories available like
Mhm.
temperature sensor. These RI charging chargers, if you adopt the temperature sensor between two cells, so
Mm.
typically in the cold area, there is a cold, there is a low temperature. So this
Hmm.
particular sensor will understand the temperature and the data logger will sense it, and accordingly RI charging will react on the battery to perform the battery charging. We called one another innovation in this era called cold logistic function available in the charger, where
Hmm.
if the battery too much cold, probably you can say 10 degree, 5 degree, or even though minus 5 and 10, the charger will understand the level of cold, and initial phase it will not charge the battery, it will warm the battery up to the
Okay.
level when the battery will easily accept the current for the converting to the charge. So that kind of a innovation process also available with this process.
Okay. Okay. Oh, that's great. That's great. So it is a smart charger. You may call it because it
You,
understand
you
what
can
the battery is
you
required.
can
Yeah.
say smart charger. That's why
Correct.
we say
Also,
that the automation solution for the charging area.
correct. Correct. Correct, sir. Okay. So, are there any plan of introducing RI charging for lithium-ion batteries, or in lithium-ion batteries you don't face such issue of excessive heating and which reduces the life of batteries?
See, a lithium-ion battery and lead-acid battery, that's a very different technology. In lead-acid
Okay.
battery, the battery don't have the BMS, battery management insight inbuilt. So
Okay.
the charger is one who is controlling the battery. Okay,
Correct.
charger
Hmm.
will take care whether to charge the battery in a proper way or the destroy the battery. So smart charging is important into the lead-acid battery. But when you talk about the lithium-ion technology, uh, the battery is having the battery maintenance, battery management system, and this BMS is configured against the type of uses, and the BMS is the smart in this case, and the charger is, so charger has to follow the instruction was BMS has given to him, and the charger had to give the appropriate output for the BMS, which is useful for battery to charge and use further. So there is a typical two different parameter. In lead
Okay.
acid, the charger is smart, and a lithium-ion battery, the battery is smart, not charger. Charger have to obey the clear instruction of the battery in lithium-ion. So here RI charging is not required in lithium ion. The proper communication, like the communication gateway, the communication between battery, BMS, and charger through the communication language, and the effectiveness of that communication is more important here.
Okay. Great. Great. So the next question would be, are there any potential downsides or limitations that you see in RI charging process that users should be aware of?
Uh, Definitely, there is no downside. Things are there because 75 years of experience there with the Fronius. They have researched,
Correct.
continuous research. So they have not keep any lacuna there that will if affect the battery charging. Absolutely not.
Okay. Okay. That's great, Aman. Okay. And any message that you wish to give to our uh, MHE users who means who use conventional type of uh, chargers and would like to switch to RI.
Yeah. See, basically, as we started with our
Mhm.
presentation, sustainable
Correct.
energy. Every company at this moment are looking for a sustainable business practices. From the
Correct.
management side, from the production side, everywhere they are using Industry 4.0, sustainable, automation, everything's are there. Why not it
Correct.
should be implemented into the warehousing area, warehousing automation. This is the part of that to make the warehousing operation sustainable in the terms of saving of energy and the improving the battery life, because the users are they know the cost of the battery used in the material handling and what is the cost implications are there. Every year they have to invest, and
Correct.
this is the operational to improve the operational efficiency. This RI charging will be helpful there, and I would further going, I would say, being with the as a part of Fronius, we at in India, we are always welcome to all MHE customers. If they connect, they contact to Godrej. Uh, we are associated with Godrej to promoting this RI charging as a smart charging process to the Indian customer. They can contact to Godrej or maybe directly to us, and
Yes.
we will give them the solution. We are ready to understand their current bottlenecks, current problems are charging. If they have any problem, we will come to your site. We will check your current condition of fleet with the battery charging and energy consumption, and we are ready to work with you. We will do a trial with you. We are ready to give the free trial, and we will practically demonstrate you at your facility how much energy we can save to your current fleet, how it will be benefited as a sustainable energy for your management. And that is up to you further once you understand the energy saving through our joint efforts with Godrej. We will be always there support you to implement at your end, and we will be always there to support you to improve your efficiency of operation with the reduction of energy cost and reduction. The important is the CO2 emissions. That is what we are always be there. Contact us. We'll be always be there. We'll come to your place, discuss. We'll present it to you, and we'll go ahead.
Fantastic. Fantastic. Thank you for this wonderful message, sir. So there's one more question. I mean, the questions are coming. I'll take this as last question, sir.
Yeah,
Are
please.
there wait? Are there any special considerations or setting to be aware of when using tag ID guided charging?
Tag ID guided system is basically it's a accessory device is there. um, Tag ID device, once when we have first time implement on the battery,
Mhm.
there is a protocol, online protocol is there. There is a one barcode is there on the every tag ID. That
Okay.
barcode, we have to on our mobile we have to just scan the barcode. There will be one form will be there. We have to
Mhm.
put all the required data. It will be once it is we have selected and saved regarding battery voltage. It will be saved one time, and once it is saved, then this particular tag ID, whichever charger we implement, that particular charger will indicate that this it will be unique sensing. That particular charger will understand this particular battery has came to me for charging, so it
Mhm.
will automatically adopt the voltage of the battery and start charging of the battery. So this is what made it very automatically. Just first time through scanning of barcode, we have to put the necessary data. Once the data is
Mm.
put it, then it will be further. There is no requirement of alteration or addition is required there in the system.
Okay, got it. Got it, sir. Got it. So, to all our attendees, I would just like to say that we have a pasted feedback form in our chat box. I request you to send the feedback to us. And once again, sir, I wish to thank you a lot for taking out time and enlightening us with this knowledge, particularly for we being in the industry. And this is really a game changer, as we had mentioned in our introduction as well. And thank you, sir. Thank you for being with us, and thank all of our uh, viewers and audience for being with us for this time. Thank you, sir. Thank you.
Thank you, Darshit. Thank you very much for
Yes.
this platform.
Yeah.
Thank you very much.
Yes. Thank you. Thank you, sir. Thank you.